All right, so let's get started. So this is something usually it takes me like an hour to go through. I have 25 minutes. And I do want to leave some question time at the end. So feel free to just think about things as I go through it, ask questions. Don't be afraid. I'll quickly go through this. What's really relevant about my experience, it's not where I worked, but it's what I've been doing for probably the last 4 to 5 years. I've been working with pretty much hundreds of companies and helping them implement solutions for with their ML, AI. So I got to speak with a lot of different customers. I learned a lot about what they're doing. First question I ask anybody is, what are you trying to do? What's your business problem? From there, it then evolves into a conversation of what they actually need. Based off of that experience, and then I took it and put together what I feel is what's the most important thing about trying to actually implement something and not getting caught along the way. So common themes, right? How to avoid common mistakes when you're building it out. The base foundation of what you want, and essentially what it takes to actually be competitive in this environment. I mean, this thing's evolving pretty crazy now, and pretty much every day there seems to be a new AI player in the field. Everything is AI based, so how do you actually keep up with it? So basically, you all know this by now. I mean, if you've been to any of the talks over the last 2 days, what is AI? And this is typically what we've been taught growing up, all the TV shows we've seen, the cartoons, the books we've read, anything about general AI, which is essentially adaptable intellect. These are like the killer robots of the future. These are flying cars that can take you anywhere. And essentially, it's just a fear, right? What's going to happen in the future? What do we have to always worry about? And this is something you'll see. Every AI presentation in the world that talks about killer robots will always show you the Terminator, right? But this is not where we are. Where we are today, and this is exactly where people think we're going to get to. One day, essentially, AI will team up with the human intellect and surpass us. And that's a singularity where the whole world's going to collapse, we're all going to die, killer robots are going to take over. But luckily, with us, battery power is really bad, so they might actually succeed for 5 minutes before they run out of power. Then we can kind of recoup and take over again. But basically, what we have today is considered narrow or weak AI. These are things like all of our mobile phone assistants, drone technology that captures images for preventative maintenance. So you'll see a lot of oil and gas companies will use drones. They'll go along all their pipelines, take images, bring the images back, put it all together. So they can actually see things and try to predict when maintenance might be done instead of actually waiting for something to happen. I think one of the biggest things will be driverless cars. It won't be adaptable in the sense that we still have to program it to do everything we want, but it'll probably be a lot more intelligence built in because there'll be a lot more decisions to make than any of these other sources. You'll hear that we're heading into the golden age of AI today. We're still at the inception of it. We're still at the beginning. Everyone's getting excited that we can train a model to recognize a cat or a dog. You can teach a 9-month-old the same thing. And they can do it with one image instead of 15 million images and 1,000 GPUs supporting it. So, but this will exponentially grow. It'll get to the point where we'll start using AI to develop AI, and that's where you'll see this exponential growth. So, like, why should you consider it? I mean, the very first question is, why do you need it? Typically, it either has to do with increasing revenue or reducing costs. Everyone needs to be able to have a monetary value. You can't get sign-off from your CTOs or CDOs unless there's some monetary value behind it. If you want to make an investment, why are you doing this? Either you want to accelerate your R&D and you want to be able to innovate a lot quicker, so we iterate through things a lot quicker. You need to have a business problem. What are you actually trying to solve? And it has to be quantifiable. You have to be able to look at your business problem and say, where are we now? What are we trying to actually solve? And if we do build something out, what are the metrics behind it? How can you actually see that you did something correct? And mostly what you're seeing today is the bottom one is automate mundane tasks. A lot of companies are just tired of manually reading documents or different legal agreements and reading thousands of these manually. They want to be able to just get these and run them through a machine learning algorithm, have it come out with a score at the end and give you something and then move on with their lives. The things you do need is you need a lot of quality data. Just because you have a lot of data doesn't mean anything. It really needs to be quality. You have to know, does your data actually make sense? Can you take a small subset, visualize it, look at it, and say, just from a quick scan, does this actually make sense to me? Can I actually solve a problem with this at a small scale? Then you can build out a model to do it at a large scale. So it's one of the most important things to think about. As I mentioned, you definitely need somebody in your organization to champion the investment. It's not cheap. A lot of the software you'll see, a lot of the hardware you're looking to buy, whether you're in the cloud, you're on-premise, it costs a lot of money. The compute behind it costs money, the software costs money, investing in the people costs money, so you do need to have an investment for it. Why not to do this? And I'll get a little bit soapboxy here. One is you're just trying to keep up with everyone else. You think you need it and you have no idea why. Again, have a business need for it. It's one of the most important things. Why do we need to do this? What problem are we trying to solve? The other one is reducing your workforce. I've seen statistics that say within 5 years, we're going to reduce our workforce by 50% with AI. If the goal is to just replace people, you're pretty much doomed to fail at that point. I've seen organizations wipe out full groups of people to replace it with algorithms or AI, not realizing that they just lost all their domain knowledge. You can't teach a program that domain knowledge. You still need somebody to look at the results after a model's been executed, look at them and qualify whether you actually did the right thing. So keeping that domain knowledge around and actually using AI instead of reducing your workforce, but actually enabling your workforce, giving them the ability to do more. So they can actually do more with their job and not have to worry about those mundane tasks, but actually teaching them how to do something a little bit more complicated with their job. And then the other thing is you think, well, we only could do this if we're in the cloud. We have to be in the cloud or we can't do AI. And if you've seen any television commercial on AI, you think, well, I have to be in the cloud or else we're not doing this right. Not true at all. You can do AI on-prem with just a handful of servers if you really need it. It really depends on what you're trying to do. And essentially, find out if your company already has it. If you work for a large organization, I'm pretty sure you might already have groups in your organization that already have data scientists. They're probably already using some pretty cool tools. They might already have access to some really good hardware. It's amazing how I will get calls from the same company, but from different groups asking about our software. Oh, what do you do? And I'm like, you do realize you have a license, right? Oh, we do? Yeah, you have another group already building models and everything. Oh, I didn't know that. Okay, you should go ask them and actually use it. So sometimes companies really have no idea what they have internally. So it's always good to go around and find out what all your different groups are working on and see if there's something you can leverage. You might already have something in place to enable it. So the challenge is, I kind of went over a few of them. I mean, things, so what people run into is things are just scattered. You have different software installs in different places. You have data sitting all over the place. You have nowhere to put your data. People are storing their code, their scripts on their laptops, on their desktops. People are just too lazy to put it into, say, GitHub. Some may not even have GitHub. I've seen situations where modelers have been working on scripts for years and their laptop crashes and all their work goes down the drain. There was no way to recover it. You'd spend thousands trying to recover their hard drives. It's all lost. So you need some sort of centralized environment. And then, of course, one that everyone worries about is security. Can we ensure that it's secure? If we're giving access to our data to numerous people, what are they actually looking at? What are they trying to do? Can we track it, et cetera? And at the end, you want to be future-proof. There are just too many new things coming out. It's amazing what every company is developing today, from Microsoft to Google to Facebook's doing their own things, Uber's developing these new tools, and they're being really nice about putting it on the market for people to use in open source. And you want to be able to try it, but you don't want to get stuck into one solution and not be able to try something new down the line and then find out that you're falling behind again. So common pitfalls to just avoid, there's no such thing as a one-size-fits-all solution. You're going to have a disparate group of data scientists, of modelers with different educational backgrounds, with different domain knowledge, and you need to be able to accommodate all of them. You want to make sure that whatever architecture you choose is flexible, that you're just not static and you can't grow. You want to be able to grow at the speed of your organization. So the more you use these tools, the more you get into it, the more you're going to find, the easier it gets, and the more you want to automate more of your work. So you just need to be able to grow. And essentially, as you build it, you'll find out that more groups will get involved. They'll start hearing that, oh, wow, you guys are doing some cool things. Can we try it out? Of course. And then you can have a system that allows a pay to play, or else they'll just come in and they'll use all your resources, then you're stuck and not doing anything with it. So basically, this is like a situation I lived through and things that I always recommend people to avoid. So traditionally, AI, machine learning tools used to be SaaS-based. SaaS used to be the major player in the game. But as companies started to evolve, they would be connected to all these older legacy type of databases, Oracle, Teradata, SQL Server, and they would have data in all different places. They would struggle trying to keep all of this data in the appropriate source. They wouldn't be able to put it all together. And over time, they start hiring new people, and they come in, they don't have SaaS backgrounds. They might want to use things like RStudio. So, okay, let's build RStudio. Let's build our server for this group of people. You get new college graduates who are Python. All they know is Python, and Python is more popular in every school today. So you buy Python servers and you build those. And you keep on trying to accommodate it, because then you need more. You hire more data scientists. So you need more Python servers. Then they want Jupyter, because they want a notebook. They want to be able to share notebooks. So you set up Jupyter. Then you set up Zeppelin. And this just continues on. So then you have Anaconda. And then all of a sudden, you have to manage all of these servers, and you have to have them all connecting to these databases. Each of these servers has their own unique database script, because they're all Linux. So they have all Unix ODBC. And it's just a huge maintenance nightmare. Then eventually, you start getting calls from the data scientists that disk is filling up. And you're like, what's going on? And you find out none of them want to connect to these databases. They're going to grab all the data they need, copy it down onto the servers locally, and then keep it there. And now you're breaking every InfoSec rule known to man. You have PII data sitting on all these servers. People can log in. Depending on what your business does, we used to have credit reports sitting on these servers open that anyone could log in and see history of people. So you have to clean up this mess. But along the way, you're still trying to expand. Things like Spark became popular. Then you're like, well, we need something to run Spark on. So you finally decide to make the investment. You scrap all your databases, you build a data lake, you think, okay, great. We have all this, we did a really good job. Data scientists don't care, they're gonna start downloading all that data locally again. They don't wanna run in that cluster, they want everything localized, and you're back to square one. So there's this vicious cycle of trying to keep up with what you're trying to do. Meanwhile, you're still trying to accommodate them by building all these extra servers for things like TensorFlow, H2O, maybe they want distributed Python, and then who knows what else is coming down the line. So this is one of the solutions you want to avoid. You want to try to have something that can allow you to be flexible and not have to maintain thousands of applications on all these servers with all this data laying around. And IT does not want to do this. They don't want to spend their day managing and babysitting data scientists. You want to be able to enable them to do their job without you having to be playing referee around it all the time. So the goal is, how can you ease the burden? So today, containerization is popular, right? Docker, everyone knows Docker. It's an easier way to spin up an application and utilize it without needing to have access to a bunch of servers. I could spin up numerous containers on one machine. You can see that Docker was essentially the main player in the game for a while. Now there are other companies coming around doing the same thing. Containers are great, but you need orchestrators, something to help manage it. So that's where Kubernetes is really popular today, with being able to manage it. And then you want to be able to give your end users a self-service platform. Again, you don't want IT to have to manage the installation of Python libraries and R libraries. You want to give them the ability to install the tools that they need, the libraries they need, and access everything they need to do their work. And then you want to be able to have it all auto-deployable. So I'm not rebuilding the wheel every time I want to do something. I should be able just to click a button and get an environment that I need to do my work. And of course, security is always the main important thing. Ensure they can do their job, but it's secure and they're not doing anything that they shouldn't do. Click. So why cloud, right? So cloud's awesome for everything from infrastructure as a service, software as a service, platform as a service. So there's numerous types, right? So public cloud, we all know the big players. There's private cloud providers out there as well. So there's some companies that still run in their own cloud, like Apple, for example. They're on public, they also have their own private cloud. And then there's the hybrid solutions, and I put an asterisk there because really no one's doing that well. It's hard to be able to take cloud-based services and on-prem services and have them work well together. So this is something that we work on a lot with BlueData and being able to enable that. Sometimes people think it's cost effective. This is one of the funniest things that I see over time. I'd speak to a customer and I would tell them about like an on-prem solution. Oh no, we're going to the cloud, we're going to save money. I'd be, okay. And then 6 months later we get a call back. Yeah, you know, it's costing us more money than we thought. Can you come back and explain your on-prem solution? So there's this pendulum shift. You'll see companies try to fully migrate and they kind of come back and they kind of find this happy medium between keeping things on-prem, keeping things in the cloud. What's nice though about the cloud is easy access to advanced infrastructure. You can't always buy the latest and greatest GPU that's on the market, but you can trust that it'll be available pretty quickly on one of these cloud providers so I can go and try it out. And then they're all investing heavily in AI today, everywhere from AWS, Azure, Google AI. So there's a lot of great tools out there at your fingertips to use. Why not to use it though? You're pretty much stuck in what they're trying to tell you to do. They're telling you how to develop data science, how to develop your machine learning tools. You have to use their step-by-step, and some of them are really not that intuitive. They're really brittle, they're painful to use, and really, they're just kind of gateway drugs to selling compute. That's all really these cloud providers are doing. They want to sell you compute. They want to charge you money for using CPU and GPU by the hour. So they give you access to these tools for free, and then you're pretty much stuck using them forever and you can't get back out. Migrating away is pretty difficult once you get all your services tied into a single cloud provider. And then there's still a huge sort of fear about security. A lot of companies trust the cloud, and there's a lot that just don't. Financial institutions right now will stay away from it. The cloud's a 4-letter word to them. They don't want to go near it. So there's still a whole trust factor around it. So the whole goal is you want to be able to be agile. You want to give the speed and the flexibility of getting all of your people onto a stack where they can have access to all the tools they need, have access to all the data they need, but not having to move all that data around, keeping the data at the source, having access to the tools they need, and then being able to be completely flexible and agile and being able to spin up any cluster they want, spin it down, and everything else. One thing I'll note is I'll actually share this deck, so if you guys, I'll email it, so just let me know and I'll send you a copy. It's pretty big, so I'll put it on my S3 drive and you can just download it. But yeah, I don't mind sharing it. So one thing I've learned talking over time, what do data scientists need, right? There's a common theme. They want to be able to collaborate. They want to have security. They want multi-tenancy. As your company grows, you want to be able to divvy up your resources and your tools between different groups. Of course, things we can't provide, but we'd be happy to, are like noise-canceling headphones. And I always give a lot of coffee. Data scientists love coffee. Good coffee too, like Blue Bottle or something pretty decent, not Starbucks. But the whole goal is, right, you want a tool that can actually go and iterate through the analytic lifecycle. The whole goal is you want to be able to start at that blue arrow, my business problem, my understanding, what am I trying to do? Do I have the data for it? Then you get your data. You build your model, you test it, you find out, crap, I did a bad job. You don't have to then go through this whole cycle from the start. You want to be able to start where you left off and iterate quickly. The whole goal is fail fast, not be afraid to try something else, fail, pick yourself back up, continue on, and not lose any cycles in the process. And the whole goal is there's really complicated and really cool things out there today, like Horovod. This is something Uber put out on the market. The ability to do distributed TensorFlow, but you don't want to have to build this every time you want to do it. You want to democratize AI to a point where I'm not really an advanced data scientist, but I want to take advantage of TensorFlow. I want to be able to take advantage of a bunch of GPUs, but I don't know how to install all of these. So how can I create a container that I can just click a button and say, I want 3 of these, and I want access to this data, and I can build a model. You want to be able to give your end users the ability to do really complex development, but the easiest way possible. You don't want them spending 90% of their time just to get to a point where they can start writing code. Even things like distributed DAS clusters. You want to be able to have as many servers as you need to be able to distribute your job and split up your code over multiple servers. But again, You don't want to have your data scientists worrying about how do I build this out, how do I have to load balance, how do I have to manage it. Again, can you give them a one-click solution where they can choose a DAS cluster, how many servers, and then start running their code? So the whole goal is you want to be able to do this quickly, iteratively, without having to wait and without wasting cycles. So one of the things you'll see today is, Moore's Law, we grew up with it. Every 2 years, CPUs will double, blah, blah, blah. But a certain inflection point, probably 10 years ago, data started to completely outpace CPU growth. And data cannot process the data at the same speed anymore. And this is where GPUs came into play, and it just skyrocketed. And now it's really important today that GPUs, and you'll hear everybody saying you have to use GPUs, you can't do anything without GPUs, and it's pretty much true. And I don't know if I really need to explain how GPUs work. I'm sure you all do. If you don't, let me know after. But the whole goal is CPUs are great doing sequential type programming. You have a handful of cores. And I always like to equate the difference. Like a CPU is like a thoroughbred racehorse that needs to run 100 miles straight. It's going to do it really great. It's going to do it efficiently. It's going to get there. It might take a few hours. GPUs are pretty slow. They're slower horses, but you have thousands of them, and you're not running 100 miles. Each horse is just running 1 mile. Which one's going to finish that race faster? They'll pretty much do that a lot quicker, doing distributing your actual workload across thousands of cores instead of doing it just on a handful of CPU cores. But only a small subset of your actual code will run on a GPU. I would say, I think Google came up with an estimate, maybe 5% of machine learning code might be GPU-based. And it's a difficult thing learning how to actually use a GPU appropriately, how to use multiple GPUs, and fractional GPUs. And you're starting to see today NVIDIA starting to work on that, making it a little bit better so you can take a GPU and even divide that up onto smaller little subsets. But the whole goal is, for really complex computation, GPUs will always win over CPU. So a little bit of things, right? You want to be able to have a solution where you can do things like GPU as a service. One of the things about GPUs, they are pricey, and there are a variety of them. And most companies won't make a general investment in the same type of GPU. You can have your Tesla 100s or K80s or M50s. You might have a mix and match of them. Some platforms don't really play well with different ones. You might have a job, you send it to your system, and say you're running something in Kubernetes blindly, and your job finishes in, say, 5 minutes. Then all of a sudden you run it on another system, it takes 30 minutes, and you're wondering why. And that's because you're not sure which core. So you want to be able to manage your GPUs and send the appropriate jobs to the appropriate GPU so that you know what it's doing. And essentially, the goal is you want to be able to set expectations. At what point are you happy with your model's performance? Are you happy at 80%? Are you happy at 90%? Are you happy to get to 90% and then invest maybe twice as much to get to 92% and then double your cost to get to 94%? At a certain point, set the expectation up front when you decide on your problem, what your metrics are, what you're trying to get to, and then realize that at a certain point, it's not going to be cost effective anymore. And that's essentially it. I know I kind of rushed through, but I know I only had 25 minutes. So there's my email. Feel free to email me. I'll send you the download link to the deck if you want a copy of it, and any questions. So anybody have any questions? I know I kind of rattled on.
One question?
No?
All right.
Oh, good. Thank you.